This is Mrs. Naslund, and today we'll be doing Fluency Lesson 3, Arrays and Commutativity. Our learning targets for today are I understand and apply the array model for multiplication, and I understand and use the commutative property of multiplication. Now, first thing we have to think about is how we can group things in different ways. So I'm going to read this little scenario here. It says, David picked some apples. He could have counted them one by one, but he thought he could use multiplication to count them faster. He arranged the apples in 4 different ways and found the same total each time. Write a multiplication equation to represent each picture. Now remember, the equation is just the mathematical way of writing it so you can represent what you're trying to write. So let's go ahead and look at these different pictures that he created. First, you'll see that he has 5 apples in each group, and he has a total of 3 groups. All right, so he wrote the equation of 3 groups times 5 apples in each group equals a total of 15. Now, another way of doing it is to put it in this nice, orderly fashion, okay? But it's really the same thing. If we look, we've got 3 groups of apples. Okay, so 1, 2, 3 with 5 apples in each. So our equation is exactly the same. 3 times 5 equals 15, right? 3 times 5 equals 15. Now here, he decided to divide it up a little different. Instead of having 3 equal groups, he put it into 5 equal groups, and in each of those equal groups, he put 3, right? So it's just the reverse, right? It's 5 groups times 3 apples in each group equals 15. And you'll notice that his nice, orderly way of writing it just kind of flipped. So he has 5 rows, right, and 3 columns. We're going to keep talking about those rows and columns here in a few minutes, okay? So again, he has 5 times 3 equals 15. So you have learned that multiplication is a way of finding the total in equal groups. Can you see or make equal groups in all 4 pictures? And the question, can you find equal groups in each of these pictures? And the answer is yes, right? In exercise 1 and 2, we have 3 equal groups, right? 3 equal groups of 5. And in exercise 3 and 4, we have 5 equal groups of how many? Yeah, 3. All right, next we're going to be talking about an array. An array is an arrangement of objects in rows and columns. Each row has the same number of items, and each column has the same number of items. This array has 2 rows and 6 columns. We say it is a 2 by 6 array. Now, I want you to look at this little picture here I drew for you because it's really important to know the difference between a row and a column when we're talking about arrays. Okay? A row goes this way, goes horizontal. Columns go up and down. Okay? So we look here, we had 2 rows and we had 6 columns. Okay? So we want to write that as a multiplication equation. We're going to write the rows first and then the columns. So 2 rows, so we're going to do 2 times the number of columns, which is 6. So 2 times 6 is 12. All right? So it says make a drawing to show each array and then write a multiplication equation to represent the total number of objects. So I want you to take out a sheet of paper and I want you to write these on a sheet of paper with me. And I want you to practice drawing the array. And again, remember, the array is just the way of showing it. It's these nice little dots, basically. So we'll do the first one together here, and then I'll have you try them. A 3 by 5 array. Now remember, they're going to put the rows first, horizontal, and then the columns. So 3 rows with 5 columns. Okay, 3 rows with 5 columns. Good. So we've got 3 rows, 2, 3. We have 5 columns, 1, 2, 3, 4, 5. And our multiplication equation would be 3 times 5 equals, you got it, 15. All right, now go ahead and draw this one. It's an 8 by 2. Okay, an 8 by 2. You can pause the video if you need to. And let's see what that would look like. And then think about what the multiplication equation would be. Okay. All right, here we go. We would have 8 rows, 1, 2, 3, 4, 5, 6, 7, 8, and 2 columns. And we'd say 8 times 2 equals, and you could count all the dots. If you don't know what the number is, then you would get 16. All right, last one, go ahead and write this one down. Draw an array for 3 by 9. Again, rows first, then columns. Okay, and then go ahead and write the multiplication equation. All right, let's see how you did. We've got 3 rows, right, and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. And the equation would be 3 times 9 equals, you got it, 27. Good. All right, on this slide, we're going to be talking about the commutative property of multiplication, which states that changing the order of the factors in a multiplication problem does not change the product. So for any numbers a and b, the commutative property states that a times b is equal to b times a. That sounds way more complicated than it really is. Basically, when we talk about factors, that's just the two numbers that we're multiplying. Okay, those are the two numbers that we're multiplying. And remember, the product is the answer that we actually have. So let's look at this little equation here. We've got 2 times 3. And I'm going to show you the two arrays that were created, right? We've got 2 rows with 3, which how many little dots do I have there? 6, right? But in this case, they flipped it. So instead of saying 2 rows times 3 columns, they did 3 rows times 2 columns, right? But how many dots do I get? Yeah, 6. They're exactly the same. So the commutative property of multiplication basically means that you can switch it around and it won't matter. Okay, so if I look at my here, I can have 3 times 2 is the same as 2 times 3. 5 times 2 is going to be exactly the same if I did 2 times 5, right? It won't matter. I'm going to get 10 in both directions. Now, an easy way that I always use to help remember this one, I always think about commuting in the car, right? Cars are changing, they're driving, maybe you've been with your parents, and they change spots often, okay? One might go ahead of the other one, and then it might go behind the other one, right? So they can change spots, and it doesn't change the answer. Oh, I wrote 10 there, but I shouldn't have done that. I should have wrote 5, right? Sorry. This should have been 2 times 5. Good. So that's basically what the commutative property of multiplication states. Let's look at some examples. All right, it says, make a drawing for each of the problems and then solve. All right. Avi arranged her bottle cap collection into an array. The array had 4 rows and 9 bottle caps in each row. How many bottle caps are in her collection? So I want you to go ahead and draw your array, and then I want you to go ahead and see if you can figure out what the multiplication problem would be and then solve it and figure out how many bottle caps she has in total. So let's see how you did. Here, first I draw my arrays. She had 4 rows with 9 in each, right? Her multiplication equation would have been 4 times 9, which would have ended up being 36 bottle caps. All right, one more here. On one wall of an art gallery, photographs were arranged in 2 rows with 7 photographs in each row. How many total photographs are on the wall? All right, so go ahead and think about the array that you're going to draw, and then I want you to write the multiplication equation and then solve it. Let's see how you do. All right, so the array you should have drawn, you should have had 2 rows with 7 columns, okay? Your multiplication equation would have been 2 times 7, which equals a total of 14 photographs. Great work. Today we talked about arrays and the commutative property of multiplication.